Okay, so over here I have used a different summation because I thought it looked cooler. So, anyways, what we did was this was awful. This was garbage. So we changed it to make it cleaner. We use after phase over here. If you look over here in the thing, there's a gradient, and we can use gradient to do after phase. So we did green for going down and yellow, I guess, for going up. I don't know. It seems like the pink man is. The color I'm going to continuously use, even though it looks like Squid Game, which is probably bad. And pretty horrible. Maybe I should change it. Anyway, so if we have Fn plus Fg equals negative Ma, so the direction is internal in those cases where Fn could be a negative or positive. In this case, it's positive, while Fg is a negative here. I decided that's the notation my textbook will use for the regular mechanics, and maybe I'll change it later on. And then if there's some kind of magnitude, I will show it off. Because that's pretty much how we're gonna set it up. Uh, it's not wrong because it's internal and fg equals negative mg, and we know it. So what this kind of proves is that Fn is a reactionary force, but that reaction could be taken up by some other mechanism if you were to think about it. In this case, it is. And this is just showing off the elevator in this case. Um, yeah, and as you see, it starts to move up. So at a certain point, the elevator goes at constant velocity up, and at that point, it does balance out. That's why you only feel that bump in the beginning, and when you stop, because there's deceleration when you stop. So, in those two cases, there's some kind of change in velocity, and that causes acceleration, and this is what happens. Well, this is more of a conceptual question. What's going to happen in these cases is that you're going to get an A, B, C, D question most likely, because you're not in the stage that you can actually solve this. Uh, it's actually not that hard to solve it because mg is constant. Mass times gravity is always constant. And what you do is get the acceleration, and the acceleration is a. But to get the acceleration from 0 to whatever milliseconds, you have to figure out what the constant rate of acceleration is. It's usually not. So it's like a more of an impulse thing, um, which I guess we could make a question on the MV of sort of that, because MV is basically, if you take a derivative of momentum, it equals a force. Uh, it's another way to say force, and that's very important for fluid dynamics. That's how we get a lot of the Navier-Stokes shenanigans and all the other painful equations that make your life a misery. And fun. It's actually enjoyable once you know what the hell you're doing. Anyway, so this is the basics of. This is most likely not going to be a case of a question made out of this. It's going to be a conceptual always, and I can finally delete these two. Oh my god, those look ugly as fuck. Anyway, no, those are ugly. Yeah. Anyway, cleaner. I should change all of it to this type format. But I will admit, um, also changing things if you get something wrong is so much easier. Oh, I forgot something. Um, yeah. Anyway, so there's this one and this one. This time I think I'm gonna use this one because it looks like you can use both of them anyway. So I forgot to write that equals 0 for two of these cases. Two of these cases, as you can see, it's a negative MA. It means that the acceleration is negative. Uh, I'm assuming you kind of understand that the acceleration is, in this case, not internal, which I should probably, I don't know what to say about that. Anyways, we'll figure it out. Yeah, because you can definitely say that the acceleration is. Oh wait, if I need to write uh, assuming a is greater than 0. uh, the assumption is important. This assumption allows me to allow it to be negative because it's always a human element to this. This is like a if a the human is agreeing that we both decided that A will be positive, therefore this makes sense. That and we're assuming that for both cases the acceleration is the same from forward to backwards, which I mean, honestly it's not going to be true, but we're going to assume that, and this is going to be how I will frame it. Um, yeah, I like it very much. Okay, so we're good with these two pages, I think. If there's something that needs more clarifying, then please email me. But I think it's very clear what I'm trying to get at here. Um, now, is this one important? We're talking about. We already did Newton's, so we're pretty good. We're pretty good. We're on track. Now we have to do this question, which we're gonna definitely reframe because it looks awful. And then we're gonna go to Lego probably. Now thinking about it, maybe we should have changed some of these other stuff where I didn't really screenshot it and then just typed it all out, because it might have been beneficial for me to actually, you know, clean it. Well, we'll see. I like. I don't think it looks dirty. It looks pretty clean and readable, and the code is also clean and readable. Um, excuse me. I'm starting to think I might want to get rid of the code. Uh, I'm still thinking if I should. Excuse me. Yeah, I'll decide that later when there's more of these questions. I might delete all the codes just so you know, because I'm thinking like I'm continuously hitting that 600 page mark, um, and with all the other sections I'm gonna have to put in here, it might be beneficial for me to keep it more compact.